make it a little bit more difficult for us. However, we apply for an area. I told you before. We apply for an area. In this area, we want to build 15 to 20 turbines because, yeah, and this is what it looks like. The first column you can see is the Lake Vanern turbines, and the second one is the turbines we are considering to use for our project. They are bigger. And foundations, we use the same kind of foundations as in Lake Vanern, and you have had a very detailed description of them, so I don't have to say much more about that. But to find the site where we can install this foundation, that's really a difficult task. And so we have made scanned this area with the side scan sonar and the deep penetrating ecolumen.
And sonar sonar.
Yeah. That you use to look at the bottom. Yeah, deep penetrating. So you can see on the picture here that you can see where you have rock and where you have sediment. The rock is you see a little thin green line. That's where you have rock. So you can have rock maybe 1 meter below sediment, and then we have to verify that it's actually true, and then you have to go with the drill and drill down quite a bit to check that it's not just a big stone that we have found. We want to have solid rock, and then we can identify it as a site. And then the distance between the sites have to be according to a good wind farm layout. Can't be too close and shouldn't be too far. And in relation to the predominating wind direction. So this is a really tricky thing to do, and we need divers, we need equipment, and but we always start with this side scan sonar, and that kind of equipment is it works very well, and it's not so very expensive actually. Then we have to connect it to mainland and to a transport station somewhere. And at sea, usually we use sea cables, which are very, very expensive. Heavy, but we have found another, or considering to use another technology, putting them into some very, very strong plastic pipes. We do that on land, and we can do that on offshore also. And then also underwater you have a lot of water moving, and that's very strong things, and it will make the cables move, and then you will either they will bend and you get kind of they will break, or they will scratch and you get short circuit something. You have to protect the cables. Either you can plow them down in the bottom where you have sediment and put them maybe 1/2 meter or so below the bottom. But where you have this kind of hard bottom or hard sediments where you can't plow, we put some protection on top of them. You can see them in the bottom picture. And then we install the cables inside that first, and then we lower the whole thing down, and then it will not move by water. It will not be moved by water, and that's the also, we will have to check the bottom where we will, at the cable route, we have divers who will check it and make a video of the whole, from the wind farm into land. That's also quite important to do that. So cables have been proved to be a much bigger problem than they imagined when they started with offshore. And this is a sketch of our internal grid. We will make, we will not have a transformer station out in the sea, which you have on some large offshore wind farms, but we will have 4 cables, 36 kilovolt cables, which will go from here all the way into land, 4 parallel cables.
It's a cheap standard cable.
Cheap standard cable, but protected by either these concrete things or these pipes. That's the idea. And then to land, you can see a little bit about the distances we have here. It's from the project area, it will be some 16 kilometers. You have to translate that to miles yourself. That's about 10 miles, yes. Exactly 10 miles. I could do that. And the total length, well, the 4 times 16 will be something like that. And the internal grid is also quite big, and we also have to interconnect these 4 cables out in the wind farm to, if you get a break inside the wind farm, you don't want to, you want to have another route to take the power out.
Reduction.
Yeah. Redundancy.
Redundancy.
Yeah.
Swedish.
It works.
And then we have for land connection, actually one reason why we choose this idea with 4 parallel cables is that we can connect, maybe we can connect 2 of them to the big industry and take 2 of them to the transformer station, to the grid. That's an option. We haven't, we are not so far in our discussion yet, but we have actually 4 different points where we can go into land. This is our main option. As you can see, this is dotted line. And the other ones are, one is here. This is the big, this one would use all electricity from this wind farm. It's a very, very big factory, and it's operating day and night all year round. It's a process industry, they do that. So this is the second, and the third is here, and the fourth is to follow this. This is the cable from Lake Vanern. You can do that also. And then we have to think about the environment, and also we think about the protection of the cables also, of course. Where we have some, get close to land, there's also some traffic, shipping and that kind of things, and also a lot of poison from the factories that's stored in the sediment. So the last piece from into land we are considering to use is called banana drilling. Yeah. It's a technology. Yeah, you use steel drilling. You know what that is? Yeah. Maybe 300 meters or something into, yeah, from the out in the water into up into land. And we use this, if it's possible, also from the foundations to get the cables out from the foundation, maybe 100 meters. So we don't know if it's possible to get this equipment on, but we will check that out. It will protect the cables, because cables are kind of vulnerable also in winter when the ice is melting. This ice, they can suddenly turn like that and cut off cables. It has happened in one wind farm in Sweden, so we are thinking about that. Okay, so I'll tell you a little bit about building phase. You recognize these foundations by now, I hope. Well, Åke showed this, but I show you just some more pictures. The vessel transporting the tower. Okay, so here we are. We wouldn't expect to be able to build more 16 turbines or 20 turbines in one season. We have to do this during 2 seasons. So it's a 2-year project. Lake Vanern was also 5 turbines first year and 5 turbines next year. But now with this experience we can build some more, I think, with some good planning. It takes very, very good planning of the logistics to manage, and you also need to have some luck with the weather. It's very, very sensitive. Okay. And of course we will use the same equipment that they have, or that we already have and have experience of using, so that will be, that's the main advantage of this project actually. And the installation will take 6 to 12 months, also split down to different years. The season where we can work is actually summer months. In the winter we can't work. In the autumn it's too windy. In the winter we have ice. In spring we have birds and we have spawning fish and that kind of thing. So it's the summer from maybe April to beginning of October. Yeah, something like that. And then, after we have done this, and built this, we will have a wind power plant in operation for 20 to 25 years. That's the expected technical lifetime of the wind farm, wind turbines. The technical lifetime of the foundations and are maybe twice or 3 times that. So it's possible after 25 years to either to change the nacelle and rotor or to change also the tower but keep the foundations. But I will not be present at that time, but Åke will, so he will solve that problem. Okay. So, what are we going to do now? Do you have any questions, maybe?
Yes.
Well, first I'd like to thank you for the presentation. If you're resting your throat, you need this. I lecture in a big hall. I can be loud. Yes, sir.
This is a question for Åke.
Yeah.
You are chairman of the local power company,
Yeah.
which I assume is a customer for the wind farm.
Not in the new wind farm, but in the first one.
The first one.
They are owner.
And my question is about the cost per kilowatt hour. And do you pay a premium for it? Is it some way subsidized by one or more governments?
It's a very smart system in Sweden. We have a green certificate market. So everyone who sells electricity needs to have 17.5% of their sold electricity should be green electricity. And if you produce wind power electricity, you can sell the certificate. So you have a market in the same way like an electricity market. So it has been operating in more than 10 years now. So the producer sells certificate and the consumer or the energy company who sell that, they buy it. So the state don't have to pay. It's no subsidies from the state. So not the single. The only one was this pilot project money, and it was only 2 projects in Sweden who got pilot project money for offshore.
What's behind my question is the cost per kilowatt hour.
Yeah, the cost
different from thermal.
The break even is about 40 to 50 öre, and that you have to think quick to release your 7 cents amount. So the price this time nowadays is very low in Sweden. It has not been so low since 10 years back. So it's very difficult for many producer of wind energy. So everyone is waiting for colder winter and less rain, because all the hydropower systems are full with water reservoirs, and so it's quite difficult for the producers now. But in a normal price, about maybe 8 or 9 cents we could get paid the green certificate and the electricity. Then it's a good business.
To answer your question for Ohio, the state of Ohio and I think 28 other states have passed renewable portfolio standards. And so in the state of Ohio, by the year 2025, I believe 25% sold has to come from green resources. The political fight is what counts as green energy. We'll leave that discussion for another day. And that can be met either by producing green energy directly or by buying renewable energy credits. So the United States is trying to develop a market very similar to that. Other questions? Yes?
Yeah, I want to thank you guys for coming over, and you know, you were dismayed that we weren't the first in fresh water, you know, but there are advantages to them, you know, treading the water for us. You know, we do appreciate that. You know, I'm glad to see you're here. You know, Sarah, you know, there's been a whole collaborative in this area to work towards this. You know, I'm with the iron workers, and I happen to build my members and myself. You know, I put up the one at the Great Lakes Science Center. I had the pleasure to, you know, and it was forward-thinking people like this. You know, your foundation system. How do you settle the base? Did you say that you have to pour a base for your foundation, or is there a way that you find your level bedrock, or?
Sorry, I didn't follow exactly. How do you manage to make
your initial foundation?
Yeah, we have a form, a wooden form, that is also moved from each foundation. And it's very simple. You put it down at the bottom.
Like a coffee.
And you push down all the wooden parts. They are like this.
Right.
So you can, the bottom is like this, and you can take them down. And then you make an underwater concrete surface. Nothing high-tech about that.
Right.
You put down by tubes.
Okay.
The concrete.
Right. And the post tensioning and stuff like that, you know, I mean, we've actually used that in Cleveland, not to this particular application, but the Fulton Road Bridge is all precast. You know, panels that are pieces that were put in, and then the cables were shot post tension. You know, so it's nice to see it in this application. You know, we got plenty of trained people here to help you when you go to build. Thanks for coming over.
Yeah, thank you.
Yes, ma'am.
I assume there are some environmental concerns with wind power, both for humans and for, you know, ecosystem. What might they be?
Can you take it?
Yes. Well, that's no problem. Okay. We have made very many investigations. We have had ornithologists checking on the migration routes, so they're not passing this area. We have had a dialogue with the fishermen. We had, I think, 4 or 5 meetings with them and discussed. And there's no fish on this area. There's fish very close to this, so we have moved some of the turbines. As a result of this dialogue, we have moved some turbines. And then we have, or the border of the area, I should say, and also we have moved the turbines also a little bit out from the coast to take concern of some birds also, which aren't a problem actually. But we have investigated things so much, and we can't find any environmental problems actually. So that's why we will get permission to do that.
Even if there was a migration route for birds, we know that they see the wind turbines, and there have been a lot of investigation in Sweden. We have followed 40 million that bird, and they have been working in this area for about 10 years to follow them with radar systems, and we know that most of the birds, they in some way, they fly another way if there is an obstacle, and they see things better than humans, in fact. So there is no problem. Maybe one bird will be killed, or 2 birds will be killed in a year or so, but it's not a major problem. There's a lot of birds killed by cats or by trains, or many other things kill birds. So that's the bird problem is not a problem, but many authorities try to make this an issue. But I think we can prove that it's not a real issue.
Yeah, they have in Sweden, there's a major migration route for seafowl called Kalmarsund. It's an island and you have the mainland, and in between there will be 1 million birds flying and 7 wind turbines are standing, and in average, according to, if you make some kind of risk calculation, 17 of these will collide each year. And the hunters, they shoot 1,000 a year. So, I mean, you have to put everything in proportion. Yeah. So even if there was a migration route through this area, it wouldn't be a problem either, but it isn't. Only 2% of the birds will even get close to this planned wind farm. So.
And for mankind, I can't see the problem. You can only see benefits. I mean, you can think there's a problem that you can see them. Maybe you can see them if there is good weather condition. Maybe you can see them 20 days a year.
Yeah, 5 days a month maybe.
When the weather conditions are very good, and then you can almost see them some other days. And you don't hear them. Of course you don't hear them, but you can hear them maybe 400 meters or something. So it's perfect for that.
Yeah. What produces the highest loading on the towers and the foundations? The wind on the rotor, the waves, or the ice? What was the design driver?
The most critical is the ice. The freshwater ice is very strong. So that was the main force that we had in the next dimensions of formation. It's higher than the pressure of the turbine.
And do you think you over-designed, or you think you got it about right, or?
We hope we over-designed. The first winter, we got 50 centimeter ice on the whole lake. And it not happens more than 120, 130, or 40, 50 years or something. So we got the worst condition the first winter, and nothing happened. We have some slight problem with this. On the concrete we have a steel plate, and we were a little bit holding the money back, so we put 2 millimeter steel plate on it from the beginning. And if we had 3 millimeter, that was strong enough. So we had some problems with 1 or 2 of the steel plates.
One last one. Does the ice move in a sheet like it does?
Yeah, it can be. It's very enormous force.
I was intrigued by the fact that you felt that you had to become a politician to get this project through. Is that necessary? What does it really take that to be able to push it through?
Yes, I think it can be. It's in every region when you don't have this established, you don't have any windmills out there. It's a very, the first step is very heavy to take. So you need a lot of politicians and other stakeholders to be through the project. So you can't say that you need it, but I believe we would never have got this project if I had not gone into the politics, because there was not the interest of what you call it, mixed interest.
National interest.
There was not the national interest for wind power in the lake. And the local county, they were working it out for the state, for the Swedish Energy Agency. And they would not like to have the wind powers there. They said you can have national interest far away out in the lake. And when I was a local politician, I could call them, the energy agency, and said, hey, all the politicians in the castle would like to have this, so you have to change it. And they changed it and make it a national interest. And when it was a national interest, the county administration couldn't stop it, because they are the state's arm in the region, and they couldn't work so hard against the state's decision. So it's small things that make it happen. It could easily have been stopped.
Now that you're retired, in a couple of years, we'll have an election for governor.
Yeah. Yeah.
Two questions. The first one, how do you prevent ice from forming on the wind blade? And the second one, on the existing wind turbines, do you have sensors monitoring the performance, like how much ice loading?
You mean ice load on the foundation or on the blades?
But, I mean, the second question is about the ice loading on the foundation. The first one is about ice forming on the blade.
Yeah. We don't have much ice, the icing on blades, we don't have a problem in the lake. It's not common. We have an old turbine, which I was part of, we erected it in 1996. And it had no problem during the whole lifetime. So you have to go further north in Sweden to have the icing problem on the blades. And then they build in the heating system to heat the blade to melt the ice. So there are many manufacturers that are improving the system for the icing. So that is it's not really a problem. It's a question of costs. We have nothing special measuring of the ice pressure. It's over-designed, so we have had a retest now with the 50 centimeter, and maybe next time will be in 30 years or so.
And just on the point of ice, Carlsson has 630 millimeters of precipitation a year, and Cleveland has 930. It rains here 50% more than it rains there.
Hey,
Sorry?
use the mic.
Okay. Question?
Yes, I'm curious what role you were playing within the local Green Party or national. Did this have to become a national issue, or was it entirely local organizing was taking place?
What was it?
This was all run locally. You know, I'm a member of the Green Party local in the city, and of course it's a very small country. So when it comes to the natural interest for wind power, we have many help on the national level to get the national interest area. But personlig fråga med. Sorry, I didn't hear really. So
that was. I think that answered your question.
You know, it's very interesting that you were able to achieve the installation with a 13-meter wide vessel. I've been attending.
It's not 13 meter. No, the lockers are 13 meter.
Okay.
And then we built these pontoons on each side. So it made it 30 meter
Okay,
wide.
30 meters. Okay.
And about 85 meter long.
Okay.
And it was, it was licensed by the Lloyds or the Norwegian Veritas, it's institutes. So it was a long procedure to get it licensed, and it cost a lot of consultant hours.
Yeah, I guess, the point there was, since you did not use jackup barges, one of the things that, in all the conferences, a lot of the conferences that I've been to in Germany and also in the Netherlands is, they're pointing, hey, this is the lowest cost, the most efficient. But I guess your wind speeds, what was your wind speed or your wave height maximum?
For the work.
For the work when you did it? The
it
water
was
always looks calm.
6 meters per second.
Okay.
And the wave height, it depends on from what wind direction we have. It was about only a half meter or something.
Okay.
But that was not really a problem. We could find this, we have very, very attention to the meteorological institutes, and we have special reports, and we plan the work. So you always get these windows when they're not windy. Then you have to work 24 hours or 20 hours. 2 teams or 3 teams. So But the main reason is that the lockers are so narrow that we couldn't get any jack up really any time into the lake. And there's also the bedrock bottom is quite steepy, and it can be difficult to put down the jack up legs because it can go away. So it depends on what kind of bottom you have. So it's better to not press on the bottom environmentally. You don't have to argue for what will happen with this bottom here. So we can have less investigations to do, maybe not affecting the bottom.
Thank you.
What is the availability of the wind farm, given the variability in wind? You know, what's the uptime percentage that you have?
You mean
It was, you know,
yeah, the return on the investment. Yeah, it's calculated to be 8 years to get the money back from the investment.
I mean, no, I'm talking about the availability. You know, what number
Oh,
of hours
for
per
the-
year
oh, yeah.
can it produce energy,
Yeah.
given the variability in the wind?
If you look at average, a wind turbine is producing the electricity in about 85% of the time, but it's a variable from very low start, cut in about 3 or 4 meters per second, and then cut out 20 or 25 meters per second. And they are available about 96% of this time. That's 96, 97%.
That's a lot. Yeah. That's good.
And that's an average in Sweden. Because there is a statistic. Everyone who got some kind of subsidiary a long time ago, they are forced to be in that statistic.
I'm just curious about the public opinion when you guys first proposed the project. Was there a lot of opposition for it? Was it very well embraced? Was it?
No, it was not a lot of opposition. Well, there was one good thing for us. It took so many years to build it, so everyone got tired. And they even thought it was already built. So when it came to the environmental court, there was no one who asked for this wind farm not to be built. There was only one who would like it to be moved. So it was very, very simple in the court, and it was about the same in this project.
Yeah, we had. We have had much public consultations. We have had public meetings informing about this, and we have had special meetings with special interest groups, and we have had meetings with the Nature Protection Society and Ornithological Society, and we agreed. We made adjustments according to what came out of these meetings. So we have been very, adaptive actually. We really tried to make everybody happy about this. The only problem we ever had, and that's actually in Sweden, the problem you have with acceptance is from public agencies. The county administration, and the Swedish Environment Agency. They don't participate in any dialogue. They don't do that. We try to have a dialogue. They don't participate.
They are there. They listen. They are there, but they don't say anything.
Yeah. And after we submit our application, then they will first they will ask for extended time to answer, to delay the project, and then they will have some really, completely imbecile. Yeah, it's absolutely. I'm telling you, you can't believe your eyes. About birds, and they say, well, maybe the eagle will fly out there. Well, what should an eagle? What is eagle? What would the eagle catch? Where there's no fish, no ducks, for just enjoyment flight or what? So we have had an ornithologist to look at this sea eagle, and okay, it flies where there are birds or fish you can catch, yeah, close to the coast. And also there's after the wind farm Lake Vanern was built, 10 turbines. There's an island 1.2 kilometers from there. A sea eagle has, according to the recommendations, the distance to a sea eagle should be 3 kilometers, 2 to 3 kilometers. Yeah, this is only 1.2 kilometers, and the sea eagle made a nest there. Yeah, didn't know the regulations. Yeah. So, because of it, that maybe 2 kilometers, 3 kilometers too much. Because the eagle, he will build his nest close to the turbines. So we have a problem with those agencies. That's really a problem.
Well, we don't have those problems.
What are the typical thickness of the sediment layers in the areas you investigated?
What sediment layers? What?
Or the thickness? Typical thickness.
Thickness. Well, the bottom, it looks like kind of the Swiss Alps, you know, like this. And we are building on the tops of these mountains. So and the thickness somewhere is 5 meters, or in the valleys you have sediment, you know, but in between there's nothing. So it's very different sea bottom than you have here, I think.
Yeah,
here's pretty flat.
But and it, some
so
parts
so
we
it's
have
more
this kind of
pure,
very
pure
stone.
rock on the top of this,
Yeah, yeah.
and we have to blast it a bit to make it enough surface and a flat surface.
And there's a lot of what you say, streams. So the water will take away all loose sediment. So the sediment is stone hard, actually, but not hard enough to build a foundation on, unfortunately. So.
Hey, you guys are here in Cleveland today, sharing your technology. Have you had many inquiries from other places in the United States interested in this, and also worldwide? Have you had much inquiry?
No, you're first in line. Yeah. So we start here. Yeah.
We're going to Ann Arbor in a few days. But there's a lot of investors who contact us from all over the world, from Arabic countries and even from States. So we need to learn more why it costs so much to build